Okay. When I looked at what Mr. Thompson did, I was like, I would do this stuff too. So anyway, we'll see. Okay. The major focus of Algebra 2, or the way I kind of like envision the way that Algebra 2 is organized, how I'm going to be teaching it, how it's taught in the book that we are going to potentially use, is that every unit kind of tends to focus on a particular parent function, how to graph it, how to transform it, the characteristics of it, so like vertices, maximums, minimums, range, domain, that kind of stuff. And then also solving equations involving that particular parent function. So as an example, I think we're going to start, not yet, we'll get to that point. We're going to like make sure we know how to describe stuff first. But like I think we start with like absolute value functions, then the next unit will be like quadratics, the next unit will be like polynomials, I want to say. It's like higher power, functions. Anyway, and we're going to do the exact same thing every single time. We're going to like graph it, we're going to look at the domain and range, we're going to transform it, we're going to solve equations involving it, and then with some like, contextual kind of stuff too that's appropriate for that particular function. Okay? So there's going to be this like rhythm that we do every single unit, and you'll see it, and or hopefully you'll see it and stuff like that. But before we can get into that rhythm, we need to have some basics, and that's what we're talking about right here. Okay? So, we have in math something called like an interval. Okay, and this is not maybe an official definition, but we're just going to like use that here. Okay, and it is part of a number line. Okay, without any breaks. Okay, you can also think of it as just like a range of numbers. Okay, and then these intervals can be finite. Okay, which just has two endpoints. Okay, or infinite. Okay, infinite. Which has one or both. Endpoints that go to infinity, or I should say plus or minus infinity, because it could be positive or negative infinity too. Okay, so plus or minus infinity. Okay. Please, if something's like weird about my handwriting, please just say something. Ask me like, Mr. Witt, what's that word there? Okay, I apologize. My handwriting's not always the best. Okay, but let me know if you can read something, or if I need to zoom in on something too. Okay. All right. So we have three different types. Three ways to describe slash notate? Note? I think notate is a word. Anyway, three ways to notate or describe an interval. Okay, so first we have inequality notation. Okay, so something like that. We have a compound inequality, right? Where we would be describing the interval where where x is between a and b there. We would include a in that interval, right? But we would not include b in this particular case. Okay, it's just a random example here I'm making up. Okay, I'll do a couple more examples here. We could also have just a single inequality too, right? That's another way to describe inequality. Right? So just x, all the x values that are greater than a. Okay, another way to describe, an interval of numbers. Okay, here we have very clearly two, a starting point and a stopping point, right? But here, well, we kind of have just a starting point, I guess you would say. Okay, and then one more here, just to have it there. Okay? And of course, you could also do it the other way too, x less than a. We'll describe what those means. Okay, so there's just some examples, right? Here we have an x value. All of our values are between two numbers, right? So that's an interval, a starting point, and a stopping point. Here we have some values that are always bigger than a particular number, and here we have an interval describing x values that are always smaller than or equal to a particular number. Okay. The other notation we can use is set notation. Okay, and by the way I'm writing these, these are equivalent to each other, right? These are describing the same thing. You'll notice there's not that much of a difference, right? It's just using these braces here, and then putting a little x with like a bar there. So x is such that a is less than or equal to x less than b. Okay. So a little bar means such that. You want to help them. It's just like a math symbol there. Okay. Or sometimes there's a colon used here instead of that vertical bar. But vertical bar. Okay. And then we can do the same things here, right? So you can see there's like not very spectacular, right? Like it's literally the same inequality there. All we're doing is making it look more fancy with the braces and the x with the bar right there, right? So like this inequality, converting it to set notation or the equivalent set notation, well, it's going to be the same kind of story, right? We're going to put the brace x with a bar like that, and x is greater than a. Okay, and the same thing here with this one. Brace x with a bar, x is less than or equal to a, and then close the brace. Okay. If braces are troublesome for you, think about drawing an S and then like the number 2. Okay, and then for the closing brace, think about drawing the number 2 and then the letter S, but the number 2 is kind of like a little stopping, and that can be helpful if you have trouble drawing those things. Okay. See, I teach handwriting in addition to math, so there you go. All right. The last notation, and the most important one, because this is going to be the one that we really will use. Okay, so I will star this one. Okay, because this is the one we're going to be using. Okay, but you should still be able to read and interpret inequality. You should still be able to read and interpret set notation. Okay, like I said, the majority of what we're going to be using is interval notation for describing an interval. Okay, so equivalently here, all right, we can see that we are going to include a. So to include a, right, we have this special symbol right here, the square bracket. I made that a little more angly than I wanted to, but anyway. A, comma, and then b, right? And to exclude b, we're going to not include it, right, because the inequality symbol does not have an equal sign there. To exclude b, what kind of symbol do we use right here? Anybody? Parenthesis, that's right. Just like that. Okay. Include, exclude, right? Okay. And then for this one right here, this is a bit different, right? We're trying to describe x values that are greater than a. So in this case, right, we had a, which was clearly smaller than b because a less than or equal to x less than b. So a would be on the left hand because it's a smaller number. B is the larger number, so it's on the right. But here, we're trying to describe all the values x that are greater than a. So the smallest value we're going to talk about here is a, right? A is the least value what we start with, comma, and then from a, we're talking about all the x values greater than a. So we're going to just go bigger and bigger and bigger from a. So where do we stop this interval? At infinity. Yeah, positive, right? It just keeps growing, just keeps going. So we'll say infinity here. Okay, so there's our interval. Okay. Our inequality here is starting at a. For x value, we're trying to describe all the x values that are greater than a. So we'll start at a, and we'll go to infinity. Okay. Should we include or exclude the a here? I think I hear both. Exclude, right? Do we have an equal to here? No. So we don't want to include the a, so exclude it. And then what about infinity? Can you ever get to infinity? No, right? It just keeps going. Infinity is like a number, but it's a unique number you never can actually get to. So we will always, always, always put a parenthesis there with infinity. Okay? So why don't you guys go ahead and try this one right here. Fill in this blank. What's that going to be then? Again, use the earlier ones there to help guide you. Okay, we just did this one, right? So you guys try this one again. What is that in interval notation? Okay. See what you can come up with. Yeah, okay. Okay. So I do like to call on people without them raising their hand from time to time as well, which maybe that's just made a lot of you anxious. But I promise that if you don't want to do it, you can, of course, pass, and you don't have to answer. So don't feel like you're going to be put on the spot there. But that being said, I do appreciate your willingness to be brave and answer a question. I promise I won't bite your head off if you don't get it right. So let's go to actually. And I use my graphing calculator to pick a number at random, and then you have numbers next to your names here on my clipboard. So it's to try and make sure that everyone is equally able to be called upon. I don't play favorites or anything like that. All right. So, Staley, did you get an answer for this? Not sure. Okay. Let's go to. Ooh, sorry. Please be patient with me while I learn names here too. Oh, there it is. Graham. Do you have an answer for us here?
Is it parentheses, infinity, comma, a, bracket thing? The square one?
Like that? Oh, frozen. There, poof, yeah. There it is. Like that? Okay, very close, very close. If we're on this side of A, we keep going this direction, what infinity we're actually going to be going towards? Minus? Yeah, the negative. Okay. Yeah, negative. Yep. Uh-huh. Yep. If your infinity's on the left, you better have a negative infinity there, because we can't go to the right of infinity, right? Infinity plus 1, you have an argument with your friend, no times infinity, no times infinity plus 1, or yes times infinity plus 1, it's the same thing, still infinity. Okay, you can't go to the right of infinity. So if your infinity's on the left here, you got to have a negative on that side. Okay. All right. Very good, very good. So let's take a look here at some examples. All right, so let me just draw. Now we're just take a look at some graphs. Okay, so like I said, we'll dive more deeply into some of these graphs here in a little bit, but I just wanted to make sure we can like do this. Okay. Oh, I guess I should also, before I do this, I wanted to define. Yes. Let me talk about domain and range here real quick. Okay, because this is the major reason why we talk about intervals in the first place. Okay. Let's see here. Let's go to Megan. What is the domain? What is the domain described about a function? Do you remember?
I have no idea.
You forgot? That's okay. Or you're not sure right now? That's okay. That's okay. We'll move on here. Simon, back to you. Do you remember what the domain describes? Yes, the x values. Right, okay. It's all possible inputs / x values for a function. Okay? The domain is a bit different than the range, okay? I mean, duh. But I guess that's not going to make my point. My point for the domain is that sometimes we get to pick what the domain is just because of a decision, right? So sometimes the domain, the decision about the domain is made for us, right? If a domain is not described or written, we assume it's all real numbers. So if you don't ever see a domain, okay, if there's nothing that would indicate otherwise, you assume it's all real numbers, right? But sometimes there are problems that come up, and we want to exclude certain numbers from the domain, or sometimes we just want to exclude certain numbers from the domain just because, okay? And we limit our graph based on that, okay? So the domain, describing these x values, remember x values are like the independent variables, right? We get some like choice about those kind of things, right? The range, though, doesn't really have so much choice. The range is a result of the domain. So the range is the resulting, kind of like y values from those chosen x values. Okay, domain and range, right? They go together, peanut butter and jelly, okay? Domain x's, range y's, right? If you want to, help remember that, think alphabetically, right? X, then y, then z, right? Domain comes first alphabetically, range also comes second alphabetically, just like x and y. Okay. All right. Hopefully that's pretty straightforward there now. All right. So let's just take a look here at an example real quick. So let's say I've got a quadratic. Make this super easy for us, hopefully here. Okay, so there's a nice parabola. I guess we'll do this like this. It would be 2, 1. Well, I don't know, something like that. That might not be very good, but anyway, okay. Okay. So, looking at this, right, what is the domain going to be for this particular graph? In other words, what are all the possible x values here that we would have for this function? How can we describe all the possible x values? What kind of interval could we write here? Well, what's the farthest left that this graph is going to go? Right? It's going to, if we go to the left here, you can see that we're pointing down, but it's not only pointing down, it's pointing to the left too, right? So it's going to keep going out and out and out like that. So it's going to go to negative infinity. Okay? Again, parentheses. Comma, what's the farthest right we're going to go here? Infinity, right? Positive infinity, right? And again, parentheses like that. Okay? Another way you could describe this, when you have negative infinity to infinity like that, you could also put like 2 vertical bars like that and write a capital R over top of it. That means also all real numbers. That's another way to write that. You see like again, 2 bars, and then capital R there over top of it. That just means all the numbers. But this is the way we want to focus on with the interval notation for right now. So then the range is also negative infinity to infinity, right?
No.
No, it's not. Okay. Range describes the y values here. So now we're going y values, right? Y values go bottom to top, right? So what's the lowest y value we're going to get to?
No, we don't.
Negative infinity, right? Because we're just going to keep going down and down and down. What's the highest y value we're going to get to? 4. Okay. Negative infinity, obviously, parenthesis. 4, parenthesis or bracket? Ooh, I hear both. Bracket. Yeah, we get to this point, right? We get to 4. There is a point there. And again, you're kind of trusting your eyes a little bit because I didn't graph this very accurately, but we'll say we get there. In fact, it looks like I go above 4 if we're going to be really technical there, but you get the idea, right? So there is an example of how we're going to be using those intervals, right? Primarily in our description of domain and range. Okay, primarily that. Okay? All right. One other characteristic here I want to discuss, and then we'll take a look at some graphs. Okay. Anyone still writing? Sorry, am I trying to take this away? Okay. The one other characteristic that we're going to be responsible for today, okay, is end behavior as well. Which in some sense we do describe in our with domain and range to an extent. So we're going to answer the question, what happens to y or f of x as x goes to infinity or negative infinity? The way we're going to describe that is like so. Okay, we'll say as x approaches infinity, f of x approaches, and then we'll put in a blank. And we'll fill in that blank. And then we'll describe as x approaches negative infinity, f of x will approach, and then a blank. End behavior, and we'll need to draw a graph here too. I'll draw a graph. Squeeze it in over here. I'm going to try. This makes something a little more interesting than a parabola. Okay. We will be graphing things like this eventually, okay, by hand without a graphing calculator, okay. One thing, I also want to mention too is that I do plan on having like calculator active portions and non-calculator active portions of our assessments too. And I will give you a heads up about those, kind of things too. Okay? It won't be like, surprise, you've been doing this with a calculator the whole time and now you don't have a calculator. I won't do something like that too, okay. That would be cool. Okay, but there will be calculator and non-calculator portions. All right, so here's something. And then okay, so that's supposed to be a -2 there on the y-axis. That's a 3 there on the x-axis. We'll just examine this here. So why don't you guys go ahead and give it your best guess here. So take a look at this, right? As x approaches infinity, we call this end behavior. End behavior because it's what's happening to our y values as, in this case, x goes to infinity. That means as we go really, really far to the right? As x approaches infinity, what are our y values approaching as we go further and further and further to the right? Likewise here, end behavior, right? As x approaches negative infinity, that means what happens to our y values as we go further and further and further and further to the left. The ends, the right end, the left end of our function. So why don't you guys go ahead and think about it, fill it in there, see what you think, okay? What are the y values that we approach as x approaches infinity as you go further to the right? What are the y values that we approach as we go further and further to the left? Okay, so see if you can fill in those blanks there. Just give yourself a second to think about it and whatnot. Try and come up with a precise value if you can. Try and come up with a precise value if you can. So you can see, just with the graph there that I've drawn, okay, what happens to the y value? What are the y values approach as x goes further and further to the right? What are the y values that x approaches as we go further and further to the left? We'll be able to do this analysis with our calculators at some point too. If you want something else to do, go ahead and just try and describe the domain and the range of that function too. So if you want another thing to look at, try and describe the domain and the range of that function as well. Like 30 more seconds. So I'll go ahead and I'll write the domain and range up here too, just for fun. So maybe the end behavior stuff's a little weird for you, but try to do it in your range too. Okay. Allie, do you have an answer you want to share?
I do, but I don't know if it's right.
That's okay. That's okay. What do you say here? As x approaches infinity, f of x approaches
Infinity.
infinity, okay. And then you're saying here, as x approaches negative infinity, f of x approaches
The negative infinity.
negative infinity, okay. Let's see here. What is somebody else? So we're saying, I'll put these in. Okay, so as x approaches infinity, f of x approaches, and we're saying maybe infinity with a question mark. And as x approaches negative infinity, f of x approaches, and you said negative infinity here, right?
Yeah.
Negative infinity? Question mark? All right, let's get a few more options here. Okay, a few more answers. Let's go to, oh my gosh. There's got to be a better way, but I don't think there is a better way. Karina, do you have an answer for us? Nothing? Okay, that's fine. All right. Let's go to Natalie. You have an answer for us?
No, I said as x approaches infinity, f of x approaches -2.
-2, okay.
Yeah, and as x approaches negative infinity, f of x is approaching 0.
0. Okay. All right. Good. One more person here, just to kind of, give people some chance to answer here. How about Christian? What do you say?
It's not right.
It's not right?
No.
Okay. It's neither of those.
Not answering.
Okay, fair enough. Pass, huh? Fair enough. Brooke's not here. All right, let's try and get one more answer then at least. How about Evelyn? Do you have an answer for us? Both approach 0. Okay, so 0 and 0 like that, huh? Okay, so let's see what's going on here. So as x approaches infinity, so we're going which direction? X going to positive infinity is which direction on our graph here? To the right. So let me just follow along with my finger here. So I'm going to start on this part of my graph, and I move to the right, move to the right, move to the right. Ooh, it goes down to negative infinity there, right? But does my graph stop here? Have I gone all the way to the right that I can? No. So I'm going to have to like jump up to here and continue moving to the right, right? Moving to the right, moving to the right, moving to the right, moving to the right, moving to the right. And this arrow would indicate that we're going to continue going this direction, right? Now it's kind of hard to see here. Some of us maybe would interpret this as like, well, Mr. Wade, that arrow's like kind of pointing down, so it's going to keep going down. And I can see that interpretation here. That was my mistake in drawing it, okay? I really was trying to point out that this thing flattens out, okay? So if it does, in fact, flatten out here to this dotted line, what is the y value we're going to ultimately approach as we go further to the right? It's going to be -2, right? So the answer here is -2 in this case. Okay, let's take a look at this next one here. As x approaches -infinity, okay, f of x will approach. So now, as we're approaching -infinity, which direction are we going? To the left. Okay, so I'm going to start over here. We're going to go left, 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 left. Oop, it goes up to positive infinity, but I'm not done yet. I still have more graphs. I'm going to go left, continue moving left, continue moving left. And again, this was supposed to look like it flattens out. Okay, and so as we continue going this way, we're going to continue to get closer and closer and closer to this x-axis here, it looks like. And so what y value would that be? 0. So the answer here is 0. Okay, so Allie, does that make some more sense? Christian, making some more sense there? Okay, very good. All right, and Evelyn, you're okay on that too? Makes some sense? Okay, good. So then the domain. All right, we have a volunteer for the domain? I'll just take a volunteer here. Matt, go ahead, Paige. Okay, almost. So it's going to go to -infinity, and it'll end at infinity, but we have one x value that never gets used. Where's the problem? Yeah, we split right at that 3, right there, okay? And we'll deal more with this, so don't fret, if you didn't get that one. That one was a different one. But yeah, 3 is excluded, right? Because there's this asymptote here, okay? And so we're going to exclude that 3. So in other words, I'll go from -infinity to 3, and I'll go from 3 to infinity, okay? And we'll just join those two things together. So I have to exclude that 3, and that's how we remove a single number from an interval. You go from -infinity to that number, bless you, and then from that number to infinity, but excluding it. Okay? Is there any y value excluded from the range here? Is there any y value excluded from the range? Yep. So the range is -infinity to infinity. Okay? You can see here that this arrow points down, right? So we're going to go all the way down to -infinity, right? Our graph goes up and up and up and up. We hit this -2, right? It goes through that, up to -2, so there. And then this graph continues going up. So there's no y value here that never gets hit. Right, unlike this 3, x value doesn't get touched, right? No graph part crosses that. Okay, here. But all the y values get hit. No y values get hit. So, okay, but don't fret about that. We're not going to be doing those kind of crazy complicated ones just yet. Okay, we'll get to those. Okay. So far, so good. So what's the end behavior of this function? As x approaches -infinity, that is, as we go further to the left, what's f of x approach? -infinity goes down, right? As x approaches positive infinity, as we go further to the right, what does this graph approach? It's going to go -infinity, it's going down, right? As we go further to the right, it's going down, down, towards -infinity. So in this case, both end behaviors are -infinity. Okay, both end behaviors are negative infinity there. Okay.
I have a
Question?
Why is the domain -infinity, infinity?
So remember, when we describe that end behavior, it's, as x approaches infinity and as x approaches -infinity. So the domain is going from -infinity to infinity there, right? There's the domain. It's what are the y values then doing? Okay, you can see there, in this case, the range goes from -infinity up to 4. But for the extremes, right, as you go further left and further right, they're both going to go down. Okay? So, anyway, there's that. Okay? Questions on any of that? All right. So, I think we've just barely covered what I wanted to look at. So I think I'll stop there rather than try and squeeze in one more example, just so we can kind of get things situated and all that. I do have a homework assignment for you. Okay. Oh, that's what I'll do is I'll show you how to access the homework assignment. Okay. So, since I don't have books for you, you might be like, no homework. But remember that we can access our textbooks online. Okay. So, let me do this. Click, click.